Hey everyone, we're going to continue on with the example problems that were on the note sheet. This one is talking about a ship receiving signals from two different transmitters, F and H. Transmitter H is 200 miles due east of transmitter F. So I'm going to draw myself a picture. I'm totally a visual person, so I like having the picture. So here's F, here's H. I know this distance is 200 miles. And so here's my, hyperbola. It's a little bit lopsided, but you get the general idea there. And I'm going to call my signal, I'm going to just call that point J. You can call it whatever you want. I'm just going to use J. Okay, it says that the ship receives a signal. So this is where the ship is, right? The ship receives a signal from transmitter F 600 milliseconds after it receives a signal from transmitter H. So it's going to be closer to H. Okay. And I know that, let's see, they gave me the rate that the transmission travels. So again, what I need to find first is A. In order to find A, I need to find 2A. 2A is the difference between the distances. The difference between the distance from J to F and the distance from J to H. Okay, so if I go ahead and take that 600 milliseconds and I multiply that by 0.186 miles per millisecond, because that's the speed at which it travels, right? I know then that distance, that 2A, is going to be 111.6 miles. That's my 2A, 111.6 miles, which means A is 55.8 miles. Because the distance from focus to focus is 200, I know that C is going to be half of that, so I know C is 100. And then from there, I'll do that over here. I can figure out what B squared is. So C squared equals A squared plus B squared. So 100 squared is equal to 55.8 squared plus B squared. And when you figure that out, we end up with B squared as 6886.36. Okay. So we have our equation then, x squared over a squared. When I square that, I end up with 3113.64 minus y squared over 6886.36 is equal to 1. So that's, that's a subtraction sign there. That is the equation of my hyperbola. But now there's a second part there. It says find the location of the ship if it is directly north of transmitter H. If it's directly north of H, I didn't quite draw it exactly that way, but assume these are right above each other. If it's directly north, remember here's 0, 0. I know that this distance is 100, so I know that the x-coordinate of this point is 100 comma something. I just have to figure out what that something is. Because that point is on the hyperbola, I can use my equation. I have a value for x. I can plug that in, and then I can find y. Okay, so if I plug 100 in for x, I have 100 squared over 313.64 minus y squared over 6886.36 is equal to 1. I'm not going to go through the algebra of that because I think you guys can figure that out on your own, right? You just would subtract this fraction from 1 and multiply by the denominator and then take the square root. But you end up with y, it comes out to be 123.4. That's an approximation. So when it says to find the location of the ship, you're just writing it as the coordinates, 100, comma 123.4. Okay. All right, and that last question, it says radio tower T1 is located 300 miles due west of radio tower T2. Simultaneous radio signals are sent from each tower to a ship, with the signal from T2 received 500 microseconds before the signal from T1, assuming that radio signals travel at 0.186 miles per microsecond. Determine the equation of the hyperbola on which the ship is located. If you want to go ahead and pause the video, try it on your own, and then you can come back and I'll give you the explanation. Okay, so again, I'm going to draw myself a picture. You know how much I like to have pictures. It says T1 is located 300 miles due west of radio tower T2. 300 miles. I think that's what I said. So this distance here is 300. Remember, that's focus to focus, which means that C is going to be half that at 150. Here's our parabola. Here's our ship. I'll call that S. Really doesn't matter what letter you use there. Let's see, 500 microseconds before the signal from T1. Again, I'm finding 2A, so I'm doing 500 times 0.186. That gives me 93. Okay, so 2A is 93, which means that A is going to be half of that, or 46.5. We know what C is. So we know C squared equals A squared plus B squared. So we've got 150 squared is equal to 46.5 squared plus B squared. B squared comes out to be 20,337.75. We square A, so we know that we know how to square A. So we end up with x squared over 2162.25 minus y squared over 2337.75 is equal to 1. And that's your equation. Okay, everybody, hopefully that helps. There's a couple of problems similar to yesterday's assignment just for some extra practice, and then some of this on your assignment tonight. Thanks, everybody. I'll see you next time. Bye-bye.